Hi guys, Audrey here, and this is a JAC capsule on understanding math notation. In this video, we're going to talk about the order of operations and also go into a little bit what it means to have implied parentheses. Let's do it. All right, so most of you have probably heard about the order of operations, and you have a little mnemonic device to help you. Maybe it's BEMDAS, maybe it's BEDMAS, maybe it's PEDMAS. We're going to start with PEDMAS today. So PEDMAS, which we can think of as please excuse my dear Aunt Sally, gives us the order in which we should evaluate things when we're looking at a mathematical expression. So the P, of course, stands for parentheses, which means that's what we should do first. Then the E stands for exponents. So after we've dealt with the parentheses, we're going to move on to dealing with the exponents. Then D is for division. M is for multiplication. A is for addition, and S is for subtraction. Now, this gives us the order in which we should do things, but it's important to know that the order of multiplication and division doesn't actually matter, and the order of addition and subtraction also doesn't actually matter. So I can flip those two things around, and that would be totally fine. In other words, I can do multiplication before division, or I can do subtraction before addition. So as we said, a good way to remember this is, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Now, this is really important, but more than that, understanding how to use it is important. So we're going to look at some examples of things and understand what each of these things means and how it shows up in a mathematical expression. We'll start with something super simple. Let's say that I have, for example, 7x minus 6. Well, in 7x minus 6, we have two operations going on. One of them is that minus sign right there, but one of them is the multiplication between the 7 and the x. So here we have 7 times x minus 6. So the multiplication comes before subtraction. We have m before s, which means that the first thing we would do to evaluate this would be to multiply the x and the 7 together. It also means that what's happening here is we have 6 less than 7 times x, not 6 less than x all times 7. So there's a big difference there. 6 less than x all times 7 would look like this. It would say those parentheses are there, meaning first we're going to subtract the 6 away from x, then multiply it all by 7. But here what we have is 6 less than x times 7, or 7 times x. Now, another example would be 7 minus 3 times x plus 2. So here we've got a few things going on. We've got that minus sign right there. We've got a plus sign right here, but we also have this multiplication. And we have the parentheses. So the first thing that we would want to do then is deal with the parentheses. So the parentheses tell me that I need to do what's inside of them first. That is my very first step. So here that means the first step, that addition is going to take precedence over anything else because it is inside the parentheses. So here we would add the x value to the 2. So what that means is after we've added the x value to the 2, we would have 7 minus 3 times some number, and then that multiplication would come next. So I can't just do 7 minus 3 first, those parentheses, and then that multiplication takes precedent. So first I'm adding the x value to the 2. My second step here would then be to multiply the 3 times whatever value you get. Multiply the 3 by the result. What that means in terms of simplifying this, if I wanted to simplify it, I have to deal with the parentheses first. If I don't have an x value and can't plug that in, then the first thing I would do would again not be that subtraction. It would still be to deal with those parentheses, which means that I would be distributing that 3 inside, and I would end up with 7 minus 3x minus 6. I'm distributing the minus 3 to get 7 minus 3x minus 6. And that would be a way to start simplifying this thing if we didn't have the x value. Here, let's make this clear what's happening. So we had in this other example. Now let's look at something where we might have to start with exponents first. So let's say we had something like 5 squared times 2 minus 3 times 4. Okay, so here we've got a few things going on. We have the subtraction, and then each of these things is a multiplication. So we have 5 squared times 2 and 3 times 4. But before I'm going to do any of those things, I want to notice that I have this exponent right here. Exponents come before multiplication. They come before subtraction. So that means my first step here would be to just evaluate 5 squared. Once I've done that, I can then multiply the 5 by 2 and multiply the 3 by 4. So if I do that, I'll end up with 25 times 2 minus 3 times 4. My second step is not going to be 2 minus 3 or 25 minus 4. I don't want to do subtraction. Multiplication comes first. So my second step is multiply the 25 times 2 and the 3 times 4. Those can happen at the same time. Now, all of this might seem straightforward to most of you or some of you, but there is one little thing that kind of changes how we think about this, and that is implied parentheses. When you first start learning math, for division, you typically learn the division symbol. So maybe I would have, I don't know, x plus 2 divided by x. And that's how you would write it. And when I write it like this, the parentheses around the x plus 2 are really important because what they tell me is that my first step is to deal with those parentheses. So in other words, my first step here would be to add the x and the 2 together. Add the x value to the 2, which is different from if I had x plus 2 divided by x. Here, this is saying the first thing that I want to do is division. So I would divide the 2 by x. I would do 2 divided by x. Second step, I'm sorry, not second step, my first step in this new thing. First step is to divide the 2 by x. So these are actually two different things that would give me two different values. However, once you get more advanced in math, we tend to stop using that division symbol. So the question is, how would we rewrite this using a fraction, which is the typical math notation used? The answer for the first one is that we would write x plus 2 over x. And notice I'm no longer writing parentheses because when we write something as a fraction, there are implied parentheses around both the numerator and the denominator. So implied parentheses, it's important to recognize that they're there because otherwise we might start here by thinking, oh, well, division comes before addition, so I can cancel out those x's and do something like this, x plus 2 over x, and cancel out the x's. But this right here is a terrible idea because we have these implied parentheses here. This is the same thing as the other thing that we have highlighted in pink here, that x plus 2 in parentheses divided by x. So again, our implied parentheses are around the numerator and the denominator. So I don't need them around the denominator in this case. Whether or not they're there, it doesn't change anything because I only have one term. But in the numerator, they are very important. It tells me that my first step is still to add the x value to 2. Now, what about this second one? How would we write that differently? So this x plus 2 divided by x. Here, the lack of parentheses is telling me that the division comes first. So if I were to rewrite this using our fractional notation, this would be x plus 2 divided by x. And that division by x, it's only going with the 2 there. And in this case, once again, there are implied parentheses around both the numerator and the denominator, but I don't need them because one, I'm using fractional notation, but I don't even have to think about them because I don't have multiple terms. There are no pluses and minuses in the numerator or the denominator. So this idea of implied parentheses is really important when we're using this fractional math notation. Another time that it's important to think about implied parentheses is when we have radicals. So like maybe I have, for example, something like 25 plus 4. Now you might be like, oh, that's just equal to the square root of 25 plus the square root of 4, which is equal to 5 plus 2, which is equal to 7. But this is not true, totally wrong. The square root of 25 plus 4 is just equal to the square root of 29. What told me to do that addition first? The fact that that radical is there, or the root. Those roots act in the same way as parentheses. So anytime you have a root, you have to think of it in the same way you think of parentheses. In other words, it's like there are implied parentheses around anything inside of a root. Implied parentheses around anything inside of a root. So this idea of implied parentheses is super important because without it, you make small mistakes that actually lead to really, really huge problems. So make sure that you don't accidentally cancel out x's that you're not allowed to cancel out, and make sure that you don't accidentally distribute powers when you're not allowed to. Those parentheses come first. So with that said, I'm going to leave you with a task. I want you to tell me, is this true or false? X plus 2 divided by 2. Can I say that this equals 2x? Take a second, think about it, come back, and I'll give you the answer. All right, so the answer is this is definitely false. I cannot cancel those 2's out and just say that this is equal to x. In this case, my first step would be to evaluate the x plus 2. There are implied parentheses around it. If I wanted, I could even rewrite this as 1/2 times x plus 2 and bring those parentheses back so it's really clear that those 2's don't cancel out. All right, so please keep in mind this idea of implied parentheses when you are simplifying things, and I'll see you guys in the next video. Bye!